This is Algebra 2 with trig, 13.2, 13.3. We're looking at the unit circle. The unit circle, if you think about graph paper and you zoom all the way into the origin, you have all these lines going up and down on your graph paper and right and left on your graph paper. The unit circle is that one square kind of that would include one unit off to each side. So that's exactly what you're looking at. It's just graph paper and you're zoomed all the way in. One unit to the right, one unit up, left, and down. So your circle has an origin of 0, 0. That's why there's nothing added or subtracted to the x and the y. And the radius is r squared. So the square root of that is just 1. The center is 0, 0. And if that's r squared, you take the square root of 1 and you get 1. So the radius is 1. That is your unit circle. Now, if we are going to zoom in, I'll do that again here. Let's zoom in here a little bit. Let's consider, what do they mean by what are the y values? Any point, we make a triangle. That just happens to be a triangle I made. It doesn't have to be a special type of triangle. It's just a triangle. Okay. Now, if the angle we're referring to is right here, right? This is the angle when we draw our angles. It's the angle from the x-axis up to your terminal side. If we think about calculating what this x value is right there, you would do the adjacent side over the hypotenuse. We know what the hypotenuse is. On a unit circle, it's 1. So cosine of our angle is going to be adjacent over 1. And anytime you have a number over 1, the cosine of theta would just be x. So every x value is just the cosine of the angle. So if you're at a 45, 45, 90 triangle, you know that the x is the cosine of 45. You're at a 30-degree angle. The x value, how far to the right that you have to go to get up to about 30 degrees, is going to be the cosine adjacent over hypotenuse of 30 degrees. So the cosine of 30, we all know, is a half. So the x coordinate here is the cosine of theta equals x. Or it's the cosine of theta. Now the y value is always the distance up above the x-axis or down from the x-axis, but it's always above or below the x-axis. So that's your opposite over hypotenuse. So that's your sine of theta equals the y value over 1. So sine of theta equals your y number. Because we have a unit of 1, it makes these calculations much easier. Because the denominator is 1, it just falls right off. It's just cosine equals the opposite side. So in knowing that, we can do tangent, which is the opposite over adjacent, which is the y value over the x value. So when we come back here to figure out the tangent, that is the y value over the x value, opposite over adjacent. You know the y value is your sine, and your x value is your cosine. So tangent is known as the sine over cosine. Now, trying to remember which is which, you know that each coordinate is alphabetical order. It's x, comma, y. It's right and left, then it's up and down. So your X comes first in the alphabet and your Y comes second. So X comma Y, that's the order of the coordinate. Well, cosine sine. Cosine comes first in the alphabet compared to sine. So it's alphabetical order. So if you're trying to remember what is the order cosine and sine that goes on your coordinate, it's going to be cosine because it's a C. It comes before the S. All right, when we're learning the unit circle, we're going to talk about the degree measures of the special angles. And the special angles that we refer to are 30, 45, and 60. All the multiples, I guess 60 is also a multiple of 30, but 30, 45, and 60 are kind of those common angles that we're looking for. And then we're going to build off of that as we move around the unit circle. For radian measures, we're going to know the radian measures for all the special angles. And your radian we've talked about is how many times your degrees goes into 180. So pi over 6 is equivalent to the 30-degree angle. The radian at 30 degrees is pi over 6 because 30 goes into 180 6 times. 45 goes into 180 4 times. So the radian is pi over 4. It's only 1/4 of the pi. And pi over 3 because 60 goes into 180 3 times. All right, our coordinates that we're going to be talking about are cosine, comma, sine. As we've talked about, X, comma, Y. Cosine comes first in the alphabet, sine comes second in the alphabet, just as your X, comma, Y is alphabetical order. And then we'll talk about what evaluating these mean. Okay, you want to memorize is their terminology. I don't love the word memorize. I like the word understand. Know how to make it. And the more times you keep making it, the more times you keep using it, the more times you'll get those shortcuts and you'll be able to jump to answers a little bit quicker. But understand how it's made. There are tons of shortcuts. Get online, you'll find tons of shortcuts. My suggestion to you is to learn how it works. And then you don't have to worry about what was that shortcut? How did you do it with the hands? There's all these crazy ways that you can do it. An angle in standard position whose terminal side is on an axis. That is called a quadrantal angle. So if you're at 90 degrees, if you're at 180, at 270, at 360, those are all considered quadrantal angles. They are multiples of 90 or pi over 2 radian. 90 degrees or pi over 2 radian. So what I'd like us to focus on first, is kind of where we left off yesterday. We made a quick little circle, all right? And we divided each of those quadrants into 3 separate values. One at 30 degrees, one at 45 degrees, and one at 60 degrees past the x-axis. So here we're at 0 degrees. When we're straight across, we're at 0 degrees. When we come up, we're at 30 degrees. Another 30 degrees, I don't have mine drawn out very proportionally accurate, that's for sure. But another 30 degrees would put your 60 out there. And the value in between would be your 45, because that's 1/4 of the pi. That's 1/4 of half a circle. Another 30 takes us to 90, and then to 120, and then to 150. Just watch where you put the 150. The 150 has to go 30 degrees later, not on the very next marker. The very next marker is part of the 45s. So 45, another 45 is 90, another 45 is 135. So from the 150, we have 30 more, which is 180, 30 more, which is 210, and 30 more, which is 240. Now you got to skip that middle one. That middle one are the 45s. The middle one would be 45 past the 180. So 180 and 45 is 225. So we're just counting by 30s and we're just counting by 45s. So 270 is 30 more, 300 is 30 more, 330, watch where you put it. You got to skip that middle one. That middle one is 45 more than 270. So that's 315. Now, some people like to focus on it more by 15s. That totally works. Don't do your first 15, but then 15 and 15 and 15. All right. And then 15, don't count that last 15. Then you keep going by 15s and you're going to land on every one of them. But you still got to not put every multiple of 15 down. Now, if we talk about radian, radian is taking the pi, we talked about last time about how pi was half a circle. It's the number of radiuses that fit around half a circle, 3.14. So 30 degrees is chopping this into 6 equal sections. So this is called pi over 6. Another equal amount, my picture doesn't quite show it proportionally, but 2 pi over 6. And then straight up would be 3 pi over 6. And 4 pi over 6. And then 5 pi over 6. Watch where you write that. You don't want to write that on the 45s. 6 pi over 6. Well, you know some of these can be reduced, but this is how you can count your way around. You don't have to necessarily memorize it, but you can make it. You understand what it means to be 5 pi over 6. 1, 2, 3, 4, 5. Count your way around. So this is 7 pi over 6. 30 more degrees takes you to 8 pi over 6. Yes, that can be reduced. 9 pi over 6. Yes, that can be reduced. 10 pi over 6. And then 30 more degrees, 11 pi over 6. And of course, 12 pi over 6. And yes, that can be reduced. And then the ones that we haven't done yet, the ones that we left blank, the middle ones on every quadrant, are pi over 4s. That's 1/4 of the pi. So this one could also be 2 pi over 4. Those both reduce to the exact same pi over 2. This would be 3 pi over 4. Think about what comes next. Another pi over 4 takes you to 4 pi over 4. And of course, that reduces. You don't need to write 4 pi over 4, it's just pi. 5 pi over 4. 6 pi over 4 reduces to the same thing, 3 over 2. And 7 pi over 4. Then you could say 8 pi over 4 if you cared to. So that is half of our unit circle. that might be considered the easier half, but I honestly don't think the other half is any more challenging than that. It's just the other half. So we're going to flip the page. And here is our unit circle. So what I'd like you to do right now is go ahead and fill in the degrees and fill in the radian value. I would suggest try not to look back at what I just did. Develop it on your own, just the way we did it. But if you got to look back, it's always there. So if you're watching the video, pause the video, go ahead and fill out your unit circle, the degrees and the radian, and come back and check it. All right, to fill in your unit circle, to save time at the moment, you can refer back to what we did on the back, and you can check your answers to be sure everything's lining up as it's supposed to. Remember, the middle value in between is always the 45s. You always have to jump that when you're counting by 30s. What we're going to talk about next, I have passed out little triangles to everybody. So if you're at home, you can cut out a triangle that is going to be able to lie perfectly, pretty perfectly at least, on your unit circle. Okay. So we've got that laying in there. Now this is your angle. All right. So this is a 30, 60, 90 triangle. So you have a right angle here in the corner. You have a radius of 1. So if your radius is 1, your short leg is going to be half of that. So I would suggest to write the word short and put 1/2 next to it. The short side is always a half. The long leg, that would be the one currently on the x-axis, that is √3 times your half. So that is √3 divided by 2. That is your long leg. Then I would suggest to flip it over and just do the same thing again. You have short, which is a half, and you have long, which is √3 over 2. And those aren't any different rules than what we've talked about before with a 30, 60, 90 triangle. So when you're trying to figure out your coordinates, we lay this triangle down. So the 90 degrees is on the x-axis. And you can clearly see what that coordinate's going to be. How far over do we go? And how far up do we go to get to this exact location on the circle? You go over √3 over 2. You go over the x amount. So that goes first. And you're going up a short distance. What I would like you to say to yourself is long, short. Okay, you go long way over to get over there, and you go up a short way. You got 3 dots, and you got to hit all 3 dots. So you got to go over a long way and up a short way. Now we're going to change it, and we turn this triangle around so it's standing on the x-axis. You always stand on the x-axis. Now you notice how we go over a short way and up a long way. So the short way is a half, and the long way is √3 over 2. And you can continue this pattern all the way around. So we're going to flip our triangle. We're going to stand it up on the x-axis, and that brings it over here to the second quadrant. Taking notice of what your x value is going to be. you've got to go over a short distance. So this is going to be a half, but do recall that when you go to the left of the y-axis, that has to be negative 1/2 because it's an x value going to the left. So it's negative 1/2. The y value is going up. So the y value is a positive √3/2. Then we'll move our triangle around and we'll stand it on the x-axis. So go ahead, think about what your coordinate would be. Say words to yourself like long and short. How do you get over to that coordinate? You've got to go a long way to the left. That's going to be negative √3/2. You're going to go a short way up. The shortest up is a half. Over long, up short. And we can continue this all the way around this unit circle. Now we're hanging it. It's still on the x-axis. You're hanging it from the x-axis. The 90 degrees is touching the x-axis, not the y-axis. Long, short. Long to the left is negative √3/2. Long, short coming down is negative 1/2. So using the triangle gives you the visual, but when you don't have your triangle, you're still using those words long and short to yourself. So when you're looking at your next one, you have a short distance and a long distance. The short is to the left, so it's got to be negative 1/2. And down is negative √3/2. Then we flip it over, we hang it. It's touching the x-axis at 90 degrees, and you can look at your sides again. You have a short side, you have a long side. Keep saying short, long to yourself. Short is 1/2, and that's to the right, so it's positive, but it is down for the y, so that's negative √3/2. And go ahead, predict what your last one's going to be. The long distance, the short distance. X is your long this time, so that's √3/2. You're going a long way over and a short way down, and that's negative 1/2. Okay. Now you're going to take your other triangle. You'll take your other triangle and you will stand it on the x-axis, and you'll see that that will naturally line up to the point in the middle. So if you're at home, you still need to cut out a triangle that is going to fit perfectly here. You want to have this triangle, at least for the beginning parts. Gives you a good visual of what's happening. You still know that the radius is 1. And we are going to divide that by √2. So when you divide 1 by √2, and then you rationalize the denominator, we get √2/2. So √2/2 is this, the length of a 45-45 right triangle. Both legs are the same in a 45-45 right triangle. And you can flip it over and you can say the same thing. √2/2 for both your sides. So now you can imagine when you lay it on your unit circle, you can see that your x comma your y for all the 45s are going to be some type of root 2 over 2. You move to the right root 2 over 2. You move up root 2 over 2. They're both positive because it's the first quadrant. When you flip it over, you are now into the second quadrant. And you know that you're going to have negative root 2 over 2 and positive root 2 over 2. The y value is a positive. And we continue. You probably don't need to use the triangle for this anymore, because you know that it's going to be negative when you go to the left and negative when you go down. They're both root 2 over 2, because these are 45s. They're always the same. And your last one, root 2 over 2 and negative root 2 over 2. Your x is positive because it's to the right. Your y is negative because it's down. Now you've got all the coordinates for those special angles. This is the unit circle. So you know that the radius of the unit circle is 1. So you know the coordinates of all what we call the quadrantal angles. This is 1 to the right and 0 up. So it's 1 comma 0. At pi over 2, you're 0 right and left, but you're 1 up. At pi, you're 1 to the left for the x, so negative 1, and you're 0 up and down, so negative 1 comma 0. As you can imagine, you're right and left 0, and you're down 1. So all your coordinates are determined, all the multiples of 30s are determined by long, short, short, long. You can draw those in there. You got the triangle, you got a short side, you got a long side. So you know what the coordinates are. Root 3 is more than 1. So 1 over root 2 is smaller than root 3 over 2. To evaluate, down here we evaluate. We're going to evaluate sine at 135. So you go to the 135 location. You look at the sine value, which is the y coordinate. So the sine of 135 is root 2 over 2. The cosine of 210, you find the 210 line. That would be this one, being at 210. The cosine is your x value. Now, if you don't have it and you're visualizing this, you're thinking, okay, 210, that's way off to the side. That's a long way over and a short way down. I'm doing cosine. So my x value is a long way over. So that's negative root 3 over 2. And then your tangent, remember, that is your y over your x, your sine over your cosine. And at 60 degrees, your y is root 3 over 2, your x is a half. So y over x is root 3 over 2 divided by a half. So to calculate that out, you're going to say root 3 over 2 times the reciprocal, because you flip the guy and multiply when you divide fractions. And you get root 3. Go ahead and try the rest of these.